I'm Anil Kumar. Welcome to my series on derivatives and their applications. We'll take up questions from a test paper. We'll consider 5 good questions from a test paper where we'll discuss about application of derivatives. Let's begin with the very first one, which is, do the functions y equals to x cubed and y equals to 1 over x ever have the same slope? Justify your answer. So the functions are y equals to x cubed. Slope means derivative, right? So let's find dy dx. Derivative is 3x squared. Let's work with the other function, which is y equals to 1 over x. So the derivative of this function is y equals to minus 1 over x squared, right? Well, some of you may like to write this as x to the power of minus 1 and then find the derivative as minus 1x to the power of minus 2, which could be written like this. So this is the derivative dy dx. Correct. So these are the two derivatives. Can they be equal? That's what we're trying to figure out. So what you notice here is that 3x squared is always positive. That is greater than 0. And this is negative, so this function is always negative. That is, it is less than 0. So they are never going to be equal, correct? So clearly they are never equal. You could actually see for yourself that when you sketch these graphs, right, that is a good thing to understand and learn. X cube graph is kind of like this. You see, it is always increasing. Which is, derivative is always positive. On the other hand, 1 over x graph is always decreasing. So let me sketch that with a different ink. As far as 1 over x is concerned, it is kind of like this, right? This is 1 over x, always decreasing. Correct? So therefore, their derivatives can never be same. Correct? So that is how you could do it. Some of you could also extend and write this as try to equate. You may say, let's try to figure out 3x squared equals to minus 1 over x squared, just to find a point. So when you cross multiply, you get x to the power of 4 equals to negative 1 over 3. Now that is never possible. I should say not possible. For x belongs to real numbers, okay? Because x to the power of 4 is always positive. Is it okay? So these are different ways you could explain your answer. So I hope this part is clear. Let's move on to the next question. The question here is, the tangent to the graph of 1 over x squared at point 2, 1 over 4, forms a triangle with x and y axis. Find the area of the triangle in square units. So we are given the function y equals to 1 over x squared. Let's find the equation of tangent first. So the derivative of this function will be minus 2. You could write this as x to the power of minus 2. So that gives you minus 2, x to the power of minus 3. So I could write it in the denominator, right? So that's the derivative. Now we need to find the derivative at x equals to 2, since the point is 2, 1, 4, right? So we are looking into a point which is 2, 1 over 4. So the derivative of this particular function at x equals to 2 will be minus 2 over 2 cubed, which is 8, right? So which gives us minus 2 over 8 or minus 1 over 4. So that becomes the derivative at the given point. Now, let's find the equation of the tangent line. So we have done the first part of finding the slope. Now, we'll find equation of tangent line. We know slope m is minus 1 over 4. The point is 2, 1, 4, right? So we could write this equation as, y equals to slope of, let's write mx plus b first, right? Now in this case, y is 2. Y is 1 over 4, the point. Slope is minus 1 over 4. The x value is 2. We need to find b. So it is 1 over 4 equals to, we can take it to the left side, so it becomes plus 2 over 4. So that is the value of b. Adding them, we get 3 over 4 as b. And therefore, the equation of the line is y equals to minus 1 over 4x plus 3 over 4. So that becomes the equation of tangent line. Correct? So what we see here is that, let's try to sketch it, and then we'll find the area. So if this is our x-axis, that's the y-axis. Y-intercept is 3 over 4, and the slope is negative 1 over 4, right? Let's find x and y intercepts. That is better. Okay, let's find x and y intercepts. So let's find x-intercept. X-intercept means y equals to 0. So if I write y equals to 0, what do I get? In that case, we have 0 equals to minus x over 4 plus 3 over 4. Multiplying by 4 and taking x here, we could write like this also. X over 4 equals to 3 over 4. And that gives you x equals to 3. So x-intercept is 3. Now let's find y-intercept. That means x equals to 0. So if I substitute x as 0 in this equation, what do I get? I get y equals to 3 over 4. Correct? So x is 3, y is 3 over 4. The tangent line equation is right there. And it goes to these 2 points, which are 3, 0 and 0, 3 over 4. So it could be something like this, right? Now when we say we want to find area of the triangle, that means this triangle. We are finding area of this triangle formed with the tangent and the coordinate axis. Now in this particular triangle, you know that the y-intercept is 3 over 4 and the x-intercept is 3. So what is the area? So let's calculate here area. Area equals to half base times height, which in this case is half of base of 3 times height of 3 by 4, correct? So you get 9 over 8. 9 over 8. So that becomes the area of the given triangle in square units, right? In square units. So that's our answer. So we get answer as area equals to 9 over 8 unit square. Perfect. So I hope the steps are absolutely clear. Now let's take up the next question. Now the next question from our test paper is to find the equation of the normal to the parabola y square equals to 9x at x equals to 4. Now let me first sketch the parabola. It is y square equals to 9x, right? So it opens towards the right side. right? So I hope that part is clear. So the parabola actually opens like this. Okay. Now what you notice here is that at x equals to 4, we do have two values. So the question is, find the equation of normal to the parabola at y square equals to 9x, x equals to 4. The thing is that since we are given x equals to 4, what we will do is that we will actually take the point 4, 6. We'll take the point x equals to 4, y equals to 6. Let's consider the point on the right side, okay? But it could be either one of them. Okay, so I just modified this question. So let's say that's the point. So tangent will be kind of like this, right? At the point which is 4, 6. Why 6? If I substitute 4 here, I get 36, and square root of 36 is plus and minus. We could get this value, okay, or somewhere here, negative also, right? But we'll consider the positive one. So I'm cutting down, so I'm just changing this question. So normal to the parabola, this at P, which is 4, 6. So that's how I changed it. Okay. So in the first part, we'll find the slope of this tangent line. We are given y square equals to 9x. So derivative will be, you could do 2y. Well, a couple of ways. We could write 2y derivative dy dx equals to 9. So when you take derivative with respect to x, that's what we get, right? Now from here, we get dy dx as equals to 9 over 2y. To find the slope at point 4, 6, we can say dy dx at x equals to 4 and y equals to 6 will be, we'll substitute y in this case as 6. So we get 9 over 2 times 6. Right? So that gives you the derivative as, you could simplify this, dividing by 3, we get 3 over 4. Correct? So the slope of this is 3 over 4 for the given point, which is 4, 6 for us. Right? So we could actually, what I did here is just simplified this, 3 times 2 and 3 times 3. So we get 3 over 4. Perfect. Now let's look into the equation of normal. Okay. The point being considered is, again I'm writing 4, 6. Now slope of perpendicular will be negative reciprocal, which is negative 4 over 3. So the equation will be y equals to negative 4 over 3x plus b. To get the value of b, I'll substitute these values. 6 equals to negative 4 over 3, x is 4, plus b. So we can take it to this side. 6 plus 16 over 3 equals to b. Now 6 times 3 is 48. 18 plus 16 over 3 equals to b. So that gives us 1434 over 3 is equals to b, right? So we get this value 34 over b as the value of b. So from here we can write down our equation, which is y equals to minus 4 over 3x plus 34 over 3. You could write it in standard form also. Multiplying by 3, we get 3y equals to minus 4x plus 34. Bringing the terms together, 4x plus 3y minus 34 equals to 0. So that becomes the equation of normal for us. Is that clear? Now, what I would like you to do is extend and find normal. Find normal at 4 minus 6. You get my idea, right? So I'd like you to try the same question when extended to a new point, which is 4 minus 6. I hope you find this exercise interesting. Let's move on and take up the very last question of this application, where we'll try to figure out the equation of a polynomial function from given turning points. The equation here is: determine the equation of a polynomial that has turning points at 1, 6 and 3, 2. Now, there are two turning points, so we'll try to go for a cubic equation. The general form for a cubic equation is y equals to ax cubed plus bx squared plus cx plus d, right? Now, there are 4 unknowns here. We can actually find these 4 unknowns since we can form 4 equations. So we are going to get 2 equations from the given points and then 2 equations from the information about turning point. Turning point means what? Turning point means that the derivative is equal to 0, right? So that is going to give us 2 more equations. So we'll have 4 equations to solve. So it's more or less a question based on simultaneous equations, right? So let's begin by writing the first 2 equations by using these 2 points. So if I substitute 1 and 6, what do I get? Y value being 6, x being 1, we get a plus b plus c plus d, right? So we get one of our equations. I'll call this as our equation number 1. Now let's substitute 3 and 2. That means x value is 3, y value is 2. So we get 2 equals to 3 cube is 27. So we get 27a, 9b plus 3c plus d. And we'll call this as our equation number 2. Now from these 2 equations, as you can see, we can eliminate d. So if I do, let us say equation 2 minus 1, let's say equation 2 minus equation 1, then we could eliminate d. 2 minus 1, we get minus 4 here, 26a, 8b plus 2c. Let's divide it by 2, so we get minus 2. 13a plus 4b plus c, right? So this equation, we can number this equation as our equation number 3, which we got as a result of working with equation 1 and 2. Now, let's look into the derivative part. Okay, so let's go to this side now and work on the derivative. So if y is equals to ax cubed plus bx squared plus cx plus d, what is the derivative equal to? 3ax squared plus 2bx plus c. That's the derivative. And we know this derivative is 0 at x equals to 1 and also at x equals to 3, since they are turning points, right? So at x equals to 1, this is 0. So we can write 0 equals to, substituting 1 here, we get 3a plus 2b plus c. Correct? Let's call this as our equation number 4. Now, let us substitute x equals to 3. That also will give us 0. So we get 0 equals to 3 square is 9, 9 times 3 is 27, so it is 27a, 3 times 2 is 6, 6b plus c. So that gives you equation number 5. Now from these two equations, we can eliminate c, right? So we can eliminate c. So let's do 5 minus 4. So we'll do 5 minus 4. Equation number 5. Take away equation number 4. So we get 0 equals to 24a plus 4b. Dividing by 4, I could write this as 6a plus b. Right? So we get the value of b in terms of a. We could also write this as b equals to minus 6a. Okay. We'll call this as our equation number 6. Now, we have two variables. We need another equation to solve with two variables. So we can look into the combination of equation 4 on this side with 1 on that side. Rather, let's go to 3. Now these equations we can eliminate c and get the second equation in terms of a and b. Okay, so now we'll work with equation 4 and equation 3. So let's do equation 3, take away equation 4. Right, so now we are working with this equation and this equation. Okay. We want to do 3 minus 4. We want to do 3 take away 4. So if I do 3 take away 4, I get this as minus 2. 13 take away 3 is 10, a. 4 take away 2 is 2, so plus 2b. We can divide by 2, so we get minus 1 equals to 5a plus b. Right, so we get this equation. Let's call this equation as 6. We already have 7. Correct. So we could substitute b equals to minus 6a and solve. So we know what b is. B is minus 6a. We'll substitute this value of b here in equation 7, right? So what we get is minus 1 equals to 5a and b is minus 6a, so we'll write minus 6a. So that gives us minus 1 equals to minus a, and that means the value of a is 1. Correct. So now we have one of the coefficients. The leading coefficient a is 1 for us. Okay. Now once we know a, we can find b, c, and d. So let's find different values of b, c, and d. We have a equals to 1, b is minus 6a, so b is equal to minus 6a, so that means b equals to minus 6, right? So we have a and b for us. So we have a equals to 1, let's highlight it with the different ink, and b is minus 6. How do we find c? The best equation to take for c will be equation 4 itself, right? So that's a neat equation. So from here, from equation 4, we can get c as equal to minus 3a minus 2b, right? So that gives us minus 3 times 1 minus 2 times minus 6, which is minus 3 plus 12, and that is 9. So we get C as 9. Okay. So we get C equals to 9. To find D, I can use the very first equation. D is equal to 6 minus A minus B minus C, right? So D is equals to 6 minus A minus B minus C, which is 6 minus 1. B is minus 6, that makes us plus 6, and C is 9 for us, minus 9, right? 6 plus 6 is 12, take away 10, leaves us with 2. So we get C as equal to 2. So this is the value of D, right? Okay. So now we know all the coefficients. We can write down our equation, which is y equals 2. A is 1, so we have x cubed. B is minus 6 6x squared. C is 9 plus 9x. And D is 2 plus 2. So that is the answer. That is how we can get our cubic equation from the given conditions, right? Since the leading coefficient is positive, we do have a graph which is going kind of like this, right? So what you will notice is that at the first turning point, which is right there, we have a maximum, right? So you notice here that in this particular situation, we'll have maximum at 1, 6, and we have minimum at the second turning point, which is 3, 2, right? So that is what we'll get. So I hope you now understand how to find equation from given conditions. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching, and all the best.